Hello students, welcome back to this course on software engineering. Let us continue our discussion on software process activities. Yesterday we have dealt with the software requirements engineering process. What is the actual structure of the requirements engineering process? What are the activities that are involved in software requirements engineering, etc. The next step that we are going to talk about today is software design and implementation, the second of the software process activities that we have discussed. So, what is software design? Software design is the design of the structure of the components that are a part of the software product that you are going to produce. So, based on the requirements that you have gathered in the previous phase, you are now going to describe the data structures that are involved, the models that are involved, the components that you are going to use as a part of this software development. So, this design document could be a diagrammatic document or a documentation in form of text, in form of other kind of illustrations, etc. But it is going to give us the overall architecture of the system that is going to be produced. So, you are in the design, in software design, it is here that you are going to decide if you are going to reuse a certain component. Now, this is the first time we are making use of this term called reuse. Now, what is reusability? Reusability is making use of the existing code or existing software into our existing component or unit of a certain software into our product that is being developed. Now, why is this being encouraged these days? In order to avoid rework and waste of time, reusability or reuse oriented engineering is highly encouraged today. You can use existing code if they are compatible, if it is required for your software product, and reduce the amount of time that is involved in recoding what is already existing. So, it is in the design phase that you are going to decide whether you are going to use a reuse a certain component from some other product which is available for reuse. So, when you are trying to incorporate a component which is already existing, then it is in the design phase that you have to also think about the interfaces between the various components. So, you are going to think about what interfaces, how these components are going to interact with each other for the overall working of the software that we are going to produce. So, that is about the software design. Now, software design and implementation. Implementation is the main phase wherein you have requirements, based on the requirements you have designed the architecture of a system. Then this design is going to go into an executable form. That is the implementation part of your software product. So, implementation, it is a process wherein you are going to translate what you have done as a part of the design into an executable program. That is where you are going to code it using a certain programming language. Then this is the actual model of the design process that what you are seeing here in this picture. Now, what you see here is you see there are three layers here. One is the design input, the other one is the design activity, and the design output. So, the design activities here include architectural design, the interface design, the component design. All of these contribute to the database design. Now, this design activity gets the input from where what kind of input it requires for the design activity: platform information, requirement specification, and data description. These are the design inputs that you obtain in order to perform a design activity. As a result of the design activity, we get certain design outputs. What is the output of design, your design activity for a certain software product? It is the system architecture. You are going to get the overall system architecture, the database specification, the interface specification, and component specification. Let us come to the design inputs now back and see what each one of these are in detail. Platform information. Now, you have to develop a certain software product. So you should know based on your requirements what kind of platform that this is going to run on. This product is going to run on. That platform information is a essential input for your design. Now then of course based on your requirements you are going to design. So requirement specification undoubtedly is one of the input for your design activity. Data description, what kind of data is your software going to deal with? Whether it is structured data, whether it is unstructured data, whether it could be images, whether your software is going to deal with videos. That data description is another input to the design activity. So based on these inputs, you are going to do a architectural design, the overall architecture or the architecture of your software product. What would be the architecture of the software product, and that process is while you are doing the architectural design, you might come across different components as a part of this architecture, and then you might have to do an interface design on how these components interact with each other. That is the component design. So architectural design, interface design and component design, these activities basically they provide input to what kind of data storage that you require. So the database design is also specified as a part of your design activity. So from this set of activities you should realize that the output of a certain design process is nothing but system architecture, the architecture of your overall system, the database specification, what kind of the database, the specifications of the database that it requires, what kind of what are the different tables, what kind of data should go into the table, what are the attributes that are involved in these tables, etc. Then the interface specification, how many interfaces are required between what components, how are these, who is going to invoke these interfaces, how the components at what time, at what point of execution do they interact with each other, all that is the interface specification. Then the component specification, you have been using a reused component, or you have actually divided your entire software product development into different components yourself and doing it step by step. Yes, well and good, that each unit of your entire software could represent a component, and that component specification is also an output here, because you have designed the component here. It could be a reused or your own component, no issues, but as an output of this architecture, of this design activity, you get component specification. So that's the model of the design process. Next step is the software validation. So software validation is generally also called as software verification and validation. So we are going to verify if the system that we have developed, that we have implemented, is going to be a part, is going to conform to the requirements that are being specified by the customer, where we have frozen the requirements, where we have a requirement specification document, we are going to cross verify whether this software is behaving the way the requirement has been specified by the customer. That is confirmation of the system to its specification. That is your software verification. Checking and review processes and system testing happens as a part of your validation, software validation. You need to give inputs. You need to give inputs to your software in order to determine whether it is performing the duty it has to do, it is expected to do. So that is your review process. You are going to check and review whether the software is behaving in the way it is required to behave. Okay. System testing involves executing the system with what is called as test cases. Now test cases are inputs to a system testing module. Okay. Now when you want to test a module, you require what is called as test cases, and these test cases define the data that you are going to input into the system in order to test it. For example, let us think that we have created a web application form. Okay, it has a field called as say a telephone number. A telephone number, let's say the number of digits in the telephone number should not cross 10. So, your test cases, when you are trying to test whether this telephone number, what happens if I give more than 10 digits, I am trying to test the system. So, I will give less than 10 or I will try to give 11 or 12 more than 10. Now, these form the test cases. Trying to give less than 10 or more than 10 forms your one test case. Saying that, so if this input is given, test case is that give a 11 digit number input into your field telephone number. Expected output, error must be thrown by the, what is the expected output that there should be error must be given to the user saying that, oh, you have entered more than 10 digits, please check your telephone number again, right. So, expected output is an error message. Then what is the actual output of the test that I have conducted? The actual output has to be recorded, whether it gave a error message or the system accepted it accepted it. Now, whatever is the case, the output that has been received is going to be incorporated. Now, if the output was as expected, we say that it has passed the test case. If it was not as expected, then we see what is the problem. Maybe I have forgotten to put in a code to check the number of digits in the telephone number. So, I go back to the implementation part, I check my code where it has to, things have to be corrected and come back. Fine. So, this is the system testing involving execution using test cases. Okay. Any software validation, it involves validation and verification is a testing process. Okay. That testing process involves component testing, system testing and acceptance testing. What picture you see here is the testing, iterative testing architecture. Now, these are the processes. Now, why component testing? As I told you, a software product is generally, it is always advised to test a certain software product as a component by itself, component by component, or by dividing it into numerous components, than testing it as an entire unit, one unit by itself. Okay. So, that is, if you have different components as a part of your software product, each component has to be tested. Then, when you integrate these components, then the interfaces come into picture. The putting the components together into one kind of a system forms your entire system. The entire system, because it consists of different types of components, the interface between these components need to be tested. Correct. The interface between the components is tested as a part of system. So, when you do system testing, you are actually trying to test what happens when all the components are put together as a single system. Do they interact with each other as expected? Are the interfaces behaving the way they should behave? And you do the system testing. After that is the acceptance testing. Acceptance testing, it is important for you to remember that acceptance testing is done when it is being accepted. You say that acceptance test is successful when the product is accepted at the user end or at the end of the customer end. Okay. So, in the acceptance testing, as a part of testing, we are going to give user actual data. The data that the user actually wants to give to the software system when he puts it to use. That data we are going to give, rather than using the simulated data that we have been using to do the other kinds of testing. Okay, that is acceptance testing. Now, at the acceptance testing using the user data, if there are some kind of discrepancies that is found during the testing, that is, some requirement is not fulfilled, right, then you go back to that component where the testing has failed and redo it. Again, you put it to system testing and again acceptance testing. Okay, so this is a iterative process which keeps happening. So this is about software verification and validation. Now what you see here is the testing phases. We've talked about the different testing the types of testing, but this testing phases can be described in an architectural model which is a plan driven process. Okay, this entire picture tells you about a plan driven software development technique. We call this the plan driven software development technique, and you see here we call it plan driven because you see many test plans here in between. There are many test plans: acceptance test plan, system integration test plan, subsystem integration test plan, etc. So this picture here, this architecture is also called as a V model. Okay, you see it looks like a V model, so it is all a V, so it is also called as a V model. This V model, the speciality of this V model is this tells us how these test plans provide a link to us between different developmental activities, right. See here, these are all developmental activities, these are all test activities if you can see it here, right. So they are providing a link between your developmental activities. These are the arrow marks that specify the links between the developmental activities. Fine. So the requirement specification, the system specification, the system design and the detailed design. After these activities are performed, at each activity there is a acceptance plan, there is a test plan that is being generated as an output of each of these activity, and based on this test plan they provide the input to the required test process or test activity. For example, now let us say here we have requirement specification, that is the what the system should actually do, the description of what the system should actually do, that gives us the entire system specification. Based on the requirements by the customer, we give a system specification. Now you generate an acceptance test plan at this stage, right, whether it is to be whether you are going to accept whether this requirement can be fulfilled or not, and you write a test plan on how to test the requirements or the system specification that is being described. Right, you write a test plan, how to conduct the test. Now it is, as I told you, it is at the design level that you are going to actually decide on the components that you are going to be using as a part of the software product. So it is at the design level that you are going to talk about the subsystem integration plan or the system integration plan. So a small number of components form a subsystem of the entire system. Okay. Then this subsystem is also tested as a part of the test, as a part of software testing. So you will learn more about software testing in the future chapters. So for now, let us just understand that system integration, that is the component integration or component interface testing, how it can be done, how they interact with each other, how it is going to help the entire overall system to work. All the test plan is done between the system integration and subsystem integration. Okay. All after the design, when all these test plans are there, they provide inputs during the testing period. What testing period? It could be subsystem integration testing, it could be system integration testing or acceptance testing. Now, so for the subsystem integration testing to happen, the design, after the design we have coded, we have module and unit code, and now we are going to begin testing. Okay, and we are now going to begin test. You have to, after design you will have to implement it, right. You need to implement the design, you have to convert it into a executable form so that the product has to run in order to test it, correct. So that happens here, and then the testing happens. Finally, the service is the maintenance part of it. When the acceptance test is the kind of a last phase wherein the user has accepted that that the product satisfies all the requirements, right. It is the acceptance test, and acceptance test is it is, since it is performed on user data, it should be satisfactory, and then only you can deploy it. And the service part is the maintainability or the maintenance part of the development SDLC phase, the software development lifecycle phase. Fine. So that is about software, that is about the testing phases. Now the next thing that we are going to deal with is the software evolution. Everywhere there is change. So with softwares, now when you develop a certain software, you can't expect that people are going to use it as it is for the next 10 years, right? Change is inevitable, right? Everywhere it is inevitable. So it is in software. So you will need to incorporate the changes that is being specified to the software product. Fine. Now that system, the system that helps you, if the system that you have developed can incorporate the changes that have been suggested and can evolve over time, that is called a system evolution. Okay. So define the system, these are all the activities, right? Define the system requirements, whatever the system requirements, then you are going to assess the existing system. Now this is the software evolution architecture here, what you are saying is, so that means to say that I already have an existing system. Now what happens if a change is proposed to the existing system is what this picture describes. So based on the certain system requirements, you have an existing system. So the input to that is the existing system itself, right? So you are going to assess, this is an activity, assess the existing system and propose the changes to the system. Okay, you are going to propose the changes to the system based on its activity, based on the current trends. Maybe we talked a lot about why it's a challenge. All these challenges contribute to software evolution. Okay, then the system changes are proposed. You need to modify this existing system, which results in a new system. Okay, now this could end here. Or the new system when assessed again. Now it becomes the existing system, the new system. When it becomes the existing system, when it is assessed again, if there are more changes, again you will have to modify it. Okay. Once the system is modified, that modification goes to the system requirements. So this arrow, generally students forget to tell that after modification, the system, the modification is added back to the system requirements, right? So system requirements, it is added back. Fine. So this is about software evolution. Okay. Now before we actually get into the process model, now because we are talking about change, okay, so as I told you, change is inevitable. So there is something called as change avoidance and change tolerance, which you need to know. What is change avoidance and change tolerance? Change avoidance is to design and implement a software in such a way that you rethink what are the possible changes to this system well ahead of time, very well ahead of time, and then build the system. That is, you are trying to avoid the change itself. That is a little difficult, but it is called as change avoidance. Then the change tolerance. Now you build a system in such a way there is scope for improvement in this system. That is change tolerance. The system is tolerant to the change in requirements. After it is being put into use, over a period of time, it can evolve. That is change tolerance. So when you are talking about system evolution, it is also important for you to talk about change avoidance and change tolerance. Okay. Now there are all these process activities that we have been seeing so far are all incorporated as a part of software development models. Okay, as a part of these models. Now I have been telling you yesterday that these activities need not be in the same order. Some models might incorporate some activity as an individual activity, some models might integrate it as a part of it. So you could have an integration of two models, or in some model you can in one model you can use another model as a part of it. All that is possible. So there is no hard and fast rule on how we use the process activities. We learned the process activities just to understand what happens at each stage. Now if you see, the first model that we are going to talk about, a famous model, is the waterfall model. This waterfall model is a very good model to build large complex systems where you can actually freeze the requirements in the beginning itself, right. There are systems where you know hard and fast that this is a complex system and this is the requirement, and this requirement is not going to change for next say some amount of time, for some period of time, and it is very complex. Yes, you can use the waterfall model. So, what is this waterfall model? A waterfall model is the top down model that you see in this architecture here. We first give the requirements definition. Based on that, the system and the software design. Now, I do not have to talk about each of these because we already know what it is, what the requirement definition is. Requirement definition, system and software design. Based on the requirements definition, we are now going to design the system and the software. Then we are going to implement the software and test it and do a testing. So, as I told you, instead of testing the system as a whole, it is always very good to test the system individually, that is unit testing. Then integration and system testing, you integrate the different units which forms the entire system and then test the system as a whole. After you do the testing, you have to put the system into actual use at the customer end, in his environment, in his domain, on his platform. That is a challenge. You just can't deliver the software and go from there. You will have to be responsible for the operation of the software and the maintenance of the software. Okay. If you remember, if you have procured any software, they say 1 year maintenance is free and all that. So, that means that if there are any problems that you have with the software, they are going to try to fix it up for you at your end based on your usage. That is operation and maintenance. Okay. So, this is the waterfall model wherein each step is finalized before going to the next step. Okay. Fine. It is not that you can't go back to the previous step in the waterfall model. You can, but it is a little difficult. That is why we do have arrow marks, that is so that you can go back, but it is a little difficult. We will talk about it. So, these are the phases of a waterfall model which we just saw: requirements analysis and definition, system and software design, implementation and unit testing, integration and system testing, operation and maintenance. These are the phases. Now, what are the problems with this waterfall model? Now, as I told you, it is not that you can't go back to the previous step when you are at a certain phase of a software development life cycle. It is, you can, but it is very difficult to accommodate a certain change when you are actually developing the software. Okay. So, and when the customer requirements are continuously changing, because you have partitioned this project into inflexible partitioning, there's no flexibility in kind of partitioning that you have done because of the because you have to freeze the stages. It is difficult and expensive to go back to the previous stage because you have been freezing at every stage. There is inflexible partitioning, and in order if the requirements change at the customer end, it would be very difficult to go back and change the requirements. So, that is why, as I told you, it is mostly used for large systems engineering project where the system is developed at several slides. You have a large engineering project wherein you can use waterfall model, a complex system, a mission critical system wherein the requirements can be frozen and it is being developed at different parts of the organization. Then you can actually use the waterfall model. Okay. The next kind of a model is the incremental development. Now, incremental development is you are going to develop a software in increments, right. You understand when I say increments, part by part, phase by phase, little by little, that is the increment. Now, what is the big thing about this? There are this specification, development and validation are concurrent activities, right. In the incremental development, we call this is the concurrent activities. So, whatever you have to start doing, you need an outline description of the system that you are going to produce. So, the outline description, what is the system actually about? a small outline about that is going to start off, is going to kick off the concurrent activities such as specification, what the system should actually do, develop it, go back to specification, you found some problem, I think you realize that one more requirements need to be added, you go back to specification, add it, develop it, validate it, again you find a problem with like we just saw in the telephone number issue, you go back to development, then you specify it saying that the telephone number should not exceed 10 digit. It might not be there in that specification, while validating you understood or you realized, right. So, you have to go back and specify it, fine. Now, the big thing about this incremental development is that you can see here that you will get a initial version of your software product, many intermediate versions and a final version. That means to say that because you are developing the software product in form of increments, you tend to get many different intermediate versions. These intermediate versions could be in form of prototypes, right. So, now if you have a large system or if you have a software that has a lot of requirements, you prioritize the requirements, and based on the priorities in the requirements, you start developing a software product and release it as a prototype to be put into use. When it is being used, as and when the customer is going to use it, it is now your actual product is put into use, right. It is prototype is a part of your product, it is given in increments. As it is being used, you can add your at your side, you can add more requirements, develop design and develop more requirements, test it and release it as the next prototype. So, this happens, intermediate versions are given to the user as prototypes, and the user gets well ahead of time what is required of the working system, right. And finally, when all the increments are released, you can release the final version of your software product. Now, another advantage is that when you are releasing the intermediate versions, you will get feedback from the customer saying that, oh, this is not what I wanted, I expected this, I meant this, okay, in the next prototype maybe you are going to correct that and release it as the next increment, fine. So, this is about the incremental development. Now, incremental development, you are going, as I told you, it is the normal approach that is used in agile methods. We are going to talk a lot about agile methods in the coming stages, wherein we are it is not a hard and fast rule that you follow, you freeze the requirements, you freeze the design, then you freeze the implementation. There is no hard and fast rule in agile. So, you keep evolving the system based on the customer requirement. As the customer requirements changes, you keep changing the requirements and incorporating it as a part of the software. So, that is the agile one. So, evaluation is done by the user or customer proxy, right. So, evaluation is being done, you are in the incremental development, you are actually involving the user itself, because you are releasing the product in form of increments, okay. Now, that is what is here in incremental delivery, wherein an increment for use by end user is going to be deployed or released for actual use. So, this is going to give us the realistic evaluation about the practical use of the software that we are going to develop. Okay. Now, we realize that in incremental development, you are going to give a increment, you are going to give a software part by part or piece by piece. So, in that the functionality could be much lesser than what it is, then what is the functionality of the entire system. So, this kind of a incremental development what we are talking about cannot be implemented for a system that cannot be replaced. You release an increment, the customer works with it, you can replace it with the next prototype if he is not satisfied with it. But this does not work out for systems that cannot be replaced. Large complex systems, no, you cannot use incremental development. Okay. So, because these increments, they have less functionality than the entire system itself. Okay. Then this is the architecture of your incremental delivery that we just discussed. So, wherein you first outline the requirements, then you assign these requirements to increments. This is what I told you, prioritize the increments and then assign the requirements to the increments. Then you design the system architecture based on the increments and develop that increment. You are going to develop only one increment at a time at this stage. Okay. Then you validate the increment and integrate the increment with the existing increments which is already produced. You have already released a few increments, got inputs, right. Then you are going to integrate the newly developed increment after validation into it. Then you validate the system as a whole. Now, 2 increments were released, the third one you have developed, integrate it and validate these 3 increments as a system. How they work together, you will have to identify and then deploy that increment. Okay. Now, each time when you deploy, you are going to decide whether the system is complete or not. If there are more increments that are to be released, then the system is not complete, it is incomplete. So, you go back and develop the increment and validate it, integrate it, right. Validate the increment, integrate it and validate the system after integrating, deploy it. So, when the system is complete, you get the final system. So, this is as simple as this. So, you will have to just remember that it is all incremental delivery. This is incremental delivery of a final system. Okay. Now, what are the advantages or problems with this? Now, the cost of accommodating changing requirements is reduced now. As opposed to the waterfall model that we just saw. Here the cost is a little reduced because you got it well ahead of time, not after the final delivery. You got input from the customer well ahead of time. Customer feedback on development is very important for us while we are developing a software, and that is an advantage. So, you gave it really fast, right, rapid delivery and deployment of the useful software. This customer got the software product much earlier than he thought it was. Even though it was in increments, the first increment that he got was very well ahead of time. He did not have to wait for the entire software to be produced and delivered to him, right. But what is the problem with it? Problem with this, the process is not visible. Generally in organization, you require the actual deliverable in order to satisfy the management or in order to report to the management that you have done this part of the work, right. This part of the software is done and it has been accepted, right. This process is not visible and that is a problem. Then it is a very good practice that you can incorporate the customer change based on his feedback each time. But let us think once again, when you want to incorporate lot of changes that the customer has suggested to a certain software, the entire design or the entire structure of your software is going to degrade, right. It is not going to be the same as you had designed it based on the first requirement set, right. It is the performance of this software might degrade based on the number of iterations that you do due to incremental delivery. Okay. So, that is the problem. Then the next and the most famous kind of a model is the Bowen's spiral model. Bowen's spiral model, you see here that the software process activities are divided into phases. Okay, right. Each of these spirals here represent a phase of the software development model. As soon as you look at this picture, you must be wondering how to remember this picture, but it is actually simple. I will just tell you how to remember this. See this picture here, you know this is a spiral and each of these spiral represent a phase. There are some things that are common which you need to first do it. This entire spiral model 1, 2, 3, right. Beginning with this 1, 2, 3, 4. There are 4 spirals that you remember, okay. 4 spirals and this spiral model is divided into sectors, okay. Now, there is something that is common. You see here risk analysis. At every phase. As I told you, each spiral represents a certain phase in the software development, and every phase has what is called as risk analysis. Risk analysis is done at every phase of the software development in Bowen spiral model. You see here that the next thing here is prototype 1, prototype 2, prototype 3 and the operational prototype, right. So, prototypes have been developed at every phase, right. Then simulations, models, benchmarks are released beginning from here to here at this kind of a at all the phases. At all the phases you might require simulations, you might require modeling, you might require benchmark to assess the software, etc. Then, okay, so if you remember these three, the next thing that you have to remember that this spiral is divided into 4 sectors, right. These are called as the sectors. Beginning from the left hand side, the first sector is to determine objectives, the next one is to evaluate the risk and evaluate alternatives, right, and identify any kind of a risk that is involved, and then you develop, verify and verify in the next sector, and at every phase you plan for the next phase. You plan for the next phase. Fine. Now, how do we remember this spiral model? We have to read this spiral model is that we have to start reading the spiral model in the clockwise, beginning with the review. You first are going to do a review of what the software should do, that is determine the objectives, what are the constraints on the software product that I am going to develop, all that is determined here. Okay. Then at every phase we do what is called as risk analysis. Okay. So, this is this spiral model is famous because this is the model that incorporates risk analysis at every phase of software development. So, you are going to identify risks in the software development and then you give a solution to it in the very next phase, right, as you reach the very next phase. Then, okay, so the risk analysis is done. What are the possible risks that might that this system might encounter when a certain requirement is satisfied? You are going to do that analysis every time. Okay. Then prototype has been developed, okay, and then you decide on the concept of operation and then you plan for the next phase every time. You develop the requirement that is required and then verify the next level kind of a next level activity. So, requirements plan, the life cycle plan is the plan for the which is the input for the next phase. Every spiral here, this was a small spiral and this is the input for the next phase here. For the next phase, which is requirements analysis, which is validation, etc. Okay. Then after that requirements is your design, which is the next phase. Now, for that you do a development plan, do the risk analysis, develop the prototype is being developed and then you design the product. You do design, verification and validation, and based on this design, verification and validation, for the next phase you are giving an input which is the integration and test plan. Based on this, again risk analysis is done and then you have an operational prototype at the end of it, and you have detailed design, you are going to code it. Okay. So, this phase is coding and testing. Here this phase, the last spiral, you have a detailed design which is the input that we got from here, then coding, unit testing, integration testing, acceptance test and maintenance. So, that ends the spiral with maintenance as the last kind of a approach. So, this is our Bowen's spiral model. So, what you have to do is you will have to remember the 4 sectors. How these sectors are associated with each of these phases need to be explained. So, the 4 sectors are objective setting, risk assessment and reduction, development and validation and planning. Okay. Now, what is objective setting? For that phase, what are the specific objectives need to be identified in order to carry out that phase? That is objective setting. Risk assessment and reduction is risks are going to be assessed and the activities are going to be put in place in order to reduce the key risks of the overall development of the software. That is risk assessment and validation. Then the risk assessment and reduction of the risk. What is development and validation? A developmental model is going to be chosen. Now, based on the system here, this is what I told you, inside spiral model, you can decide on a model for development. Either you can decide on a waterfall model, a prototyping model, a incremental model, whatever type of model you would wish to, based on the requirements, you are going to decide on the development model for the system, which can be any of the generic models. Then you are going to plan. The planning has the planning sector. If you remember, the planning sector was, we'll just go back here. This is the planning sector. The planning sector, the project is reviewed and the next phase of the spiral is planned. So, that is what I told you when I was talking about this. This will provide us the input to the next phase, the development plan, the integration plan and the test plan, etc. will be the input to the next phase. Then what we have to remember in spiral model is what we are going to conclude today's lecture. There is no fixed phase with such as specification or design. Now, these loops in the spiral are going to be chosen based on what is required. Okay. So, you have the liberty to choose the phases in the form of the spiral loops based on what you require. So, there is no fixed type of a activity in each phase. Now, as a part of case study, I would like to tell you that just think about the waterfall model for building a university examination system, and for the incremental model, just give it a thought before we meet in the next class. We have some time in between. So, just try to think about the mechanical engineering process that is involved in the manufacturing of a helicopter or any aerospace kind of activity, or any kind of a mechanical engineering any kind of a mechanical device or something like that using incremental model, and we might want to come back and discuss on these two case studies again before we move on to the next chapter. Okay. Thank you very much.